This is SpaceTime, Series 22, Episode 66. Coming up on SpaceTime. A catastrophic rocket failure at a top-secret Iranian missile complex. India orders Russian technology for its first ever manned spaceflight. And another delay for the first test flight of Boeing's new Starliner crew transfer vehicle. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
New satellite images show what appears to have been a catastrophic rocket failure at a top-secret Iranian missile complex. The imagery, taken by both the WorldView 2 and SkySat commercial Earth imaging satellites, shows smoke rising into the sky from what was a freshly refurbished launch pad, now littered with debris, at the top-secret Imam Khomeini launch complex in northern Iran. The launch pad has a large black smudge in its center, apparently caused by a rocket explosion. The commercial Earth imaging satellite photos were backed up by President Donald Trump, who tweeted American reconnaissance satellite images providing far greater detail of the scene, including damaged fuel and support vehicles, severe scorching on the northern side of the launch pad, the damaged gantry service tower, and a damaged Sophia missile mobile launcher. The President's tweet also suggests the incident occurred during pre-launch preparations. It's the third launch failure during Tehran's current missile test program. And all three failures have involved variants of Tehran's Sophia, or ambassador missile. The first, back in January, saw the failure of the third stage of a Simor or Phoenix missile, also known as the Sophia 2. The Simir uses a North Korean Taepodong-2 ballistic missile, equipped with 4 Scud missile rocket motors, for its first stage, and a Sophia missile for the second and third stages. Then another Sophia missile failed in February, followed by this latest failure on August the 29th. Okay, so what do we know about the Sophia? Well, it's 22 meters tall and derived from Iran's Shahab or Shooting Star 3 intermediate-range ballistic missile, with the warheads removed to make room for an alternative payload. The Shahab 3 can deliver a 1,200-kilogram warhead or 5 MIRV or independently targeted multiple reentry vehicle warheads over a range of around 2,000 to 2,500 kilometers. The Shahab 3 is based on North Korea's Nodong-1 medium-range ballistic missile, which itself is based on the Soviet Union SS-1 Scud missile, sourced from Egyptian Scud-B and Chinese Scud-C missiles. The Sophia is a 2-stage liquid-fueled launch vehicle. The first stage uses a single fixed turbopump thrust chamber with 4 graphite vanes extended into the exhaust plume to provide steering. The propellants include either unsymmetrical dimethylhydrazine or a kerosene-gasoline mix. In both cases, liquid oxygen is used as the oxidizer. The second stage uses similar propellants, but it's fed through a cluster of 4 small thruster chambers by a single turbopump. As well as using North Korean technology, the Islamic Republic of Iran also copied their North Korean allies by claiming their illegal missile tests are part of a space program. You see, Iran's medium and long-range ballistic missile launches violate United Nations Security Council Resolution 2231, which endorsed the 2015 nuclear deal between Iran, the United States, and Europe, calling on Iran to refrain from undertaking activities related to ballistic missiles capable of delivering nuclear weapons, and that included missile launches. However, Tehran has continued to launch medium-range ballistic missiles, including tests using multiple warheads. In May 2018, the United States pulled out of the Iran nuclear deal, citing multiple violations by Tehran, including continued missile tests, the continued sponsorship of terrorist organizations such as Hezbollah, Hamas, and Islamic Jihad, and continuing to secretly develop nuclear weapons. See, there's continued major concern among global intelligence services that Iran is actively working on a secretive parallel nuclear weapons program with the help of the North Koreans. We know that Pyongyang has already tested and miniaturized thermonuclear warheads to fit on their missiles. And the International Atomic Energy Agency says the Islamic Republic has explored various fusing, aiming, and firing mechanisms to make its missiles more capable of reliably delivering a thermonuclear warhead. However, the oil-rich nation insists its nuclear program is for peaceful power generation only. Still, the United Nations nuclear watchdog says Iran has continued to breach its nuclear deal with world powers, both by increasing its stockpile of enriched uranium and also increasing its uranium enrichment purity closer to weapons grade. The International Atomic Energy Agency, which is policing the 2015 deal, says Tehran has both exceeded the 202.8 kilogram limit on enriched uranium stockpiles and its 3.67% cap on fissile purity. The new report says the Islamic Republic has drastically exceeded those limits, accumulating some 241.6 kilograms of enriched uranium and increasing its purity by up to 4.5%. You're listening to Space Time. I'm Stuart Gary. India has ordered Russian technology for its first manned space mission. India is still looking to launch its first manned space flight in 2022 in order to mark the 75th anniversary of its independence from British rule. The Indian Space Research Organisation has been developing its own rockets, spacesuits and life support systems. It's also established a technical liaison unit with the Russian Federal Space Agency Roscosmos in order to purchase other equipment needed for the mission. Roscosmos is also helping to train Indian astronauts. Although the Russian Space Agency won't say exactly what technology is being supplied to the Indians, Roscosmos did supply key design details to the Chinese for their first manned spaceflight, including the capsule and life support system technology. Meanwhile, a new report claims there's still more than 100 pieces of space debris floating around in orbit following a recent Indian anti-satellite missile test. The test, back on March the 27th, destroyed the 740-kilogram microsat-R target satellite, which was orbiting at an altitude of 300 kilometers. The Indian government claimed the test was deliberately conducted at low altitude to ensure the resulting debris cloud would decay quickly and fall back to Earth within weeks. However, the impact has left a massive cloud of debris circling the planet and posing a serious danger to other spacecraft, including the International Space Station and its crew. NASA warns there are still at least 101 pieces of debris big enough to be tracked. I'm Stuart Gary. You're listening to Space Time. A special unmanned test flight of a new Soyuz launch system was forced to abort a docking attempt with the International Space Station after failing to lock on to the docking target. The Russian Federal Space Agency Roscosmos carried out the test flight of its Soyuz capsule in order to qualify modifications to its launch abort system for integration with the new Soyuz 21A launch vehicle. The new Soyuz 21A booster will replace the current Soyuz FG launch vehicle, which has been used for decades to take crews and cargo into space. The 21A and its 21B counterpart use a new digital flight control system as well as upgraded engines. And unlike the traditional Soyuz launch vehicle, which is turned on its launch pad to set the flight azimuth, the Soyuz 2 performs a roll maneuver during flight to change direction. And that's something that would trigger a launch abort on the analog system designed for the Soyuz FG. Without any crew aboard, the Soyuz MS-14 capsule carried 670 kilograms of cargo. Included in the manifest was a Russian android called the Skybot F-850 robot, a two-legged, two-armed humanoid looking a lot more like Chappie than CP-30. Given the nickname Fedor, which is short for Final Experimental Demonstration Object Research, the android can be operated manually by space station crew wearing robotic exoskeleton suits and then mirrors their movements. The Soyuz MS-14 test flight blasted off from the Baikonur Cosmodrome in the Central Asian Republic of Kazakhstan on a conventional two-day journey to the space station.
The launch pad at Site 31 of the Baikonur Cosmodrome in Kazakhstan, where a Soyuz 2.1A booster is fully fueled, ready to launch to carry an unpiloted Soyuz spacecraft to orbit en route to the International Space Station for an automated docking in the wee hours Saturday morning, a critical test flight for Roscosmos in its ability to start using this 2.1A booster and the Soyuz spacecraft for crew launches beginning next March. Retraction of that first umbilical, T-minus 22 seconds and counting. The second umbilical has now retracted. This initiates engine sequence start. We have engine ignition, turbo pumps up to flight speed, and liftoff. Liftoff of the unpiloted Soyuz MS-14 spacecraft on a test flight to pave the way for future crew launches to the International Space Station. The Soyuz spacecraft now arcing out to the northeast, heading for an orbit 51.6 degrees inclined to the International Space Station for a rendezvous and docking early Saturday morning. First stage engines performing nominally according to the blockhouse in Baikonur. Good roll, pitch, and yaw program. Standing by for first stage shutdown. We have staging, 2.5 minutes into the flight, everything proceeding normally. We have jettison of the launch shroud. The Soyuz traveling 5,600 miles an hour, 58 miles in altitude, 100 miles downrange from the Baikonur Cosmodrome, heading right down the pipe. We have third stage lower skirt jettisoning standing by, and we have third stage shutdown and third stage separation. And there go the solar arrays. And the solar arrays and navigational antennas have all deployed as planned, a flawless climb to orbit for Soyuz MS-14 in its test flight, the first launch of a Soyuz vehicle on the 2.1A booster. Inside the descent module, this is Skybot, or Fyodor as it is affectionately known. He made it to orbit and is en route to the International Space Station, where he will be brought inside the Poisk module next week for 5 days of testing and experiments by Alexander Skvortsov and Alexei Ovchinin before being returned to the center seat, the Soyuz commander seat, if you will, in the descent module of the Soyuz spacecraft.
However, despite a relatively smooth journey there, the MS-14 was forced to abort its first automated docking attempt with the space station's Poisk module. It seems the Soyuz Kurs radar was unable to lock on to the space station's docking port, causing the capsule to begin oscillating from side to side as it attempted to find its target.
Flying over northern China near the border with Mongolia, the Soyuz MS-14 continues to gather data automatically for its onboard computers from its core's automated rendezvous system as we stand by for the Russian flight controllers to determine where we are at with the Soyuz MS-14 and whether or not final approach will be initiated for its automated docking to the Poisk module.
CS-47 has been sent. Copy.
Station Houston on 2, Soyuz is aborting.
Hey, Alexander. Go ahead. This is Vladimir. It's in the middle of an abort right now. Are you saying? We're trying to get a visual on the spacecraft, but we can't see it.
This is Mission Control Houston. As you heard, spacecraft communicator Tamara York here in Mission Control informing the crew on board the station that the approach of the Soyuz MS-14 to the International Space Station has been aborted. The command issued by the cosmonauts in the Zvezda service module, Soyuz now backing away to a safe distance from the station to allow Russian flight controllers to assess the next course of action, this occurring after the Soyuz encountered an issue of unspecified origin with its core's automated rendezvous system unable to lock on to the target on the Poisk module docking port of the International Space Station.
It's in the LVLH. And
the abort command from Station Commander Alexei Ovchinin issued at 12:36 a.m. Central Time. This is Mission Control Houston. The Soyuz MS-14 unpiloted spacecraft in the International Space Station flying to the northeast of the coast of Australia. The Soyuz aborted its approach. Actually, it was the cosmonauts on board the station that issued a command to the Soyuz to abort its approach after the Soyuz had problems locking its core's automated rendezvous system signal onto the Poisk docking port on the space-facing side of the Russian segment of the station. The decision has been made by Russian flight controllers not to attempt another rendezvous tonight. It is unclear as to what the next course of action will be as the Russian flight control team assesses what may have caused a problem with the core's automated rendezvous system. But the Soyuz now has backed away to a safe distance from the International Space Station.
One of the problems is the Soyuz MS-14 is not equipped with the Taurus system used on Progress cargo ships. That allows cosmonauts on the space station to take remote control of the spacecraft if necessary. A second docking attempt a week later above eastern Mongolia was more successful, with contact and capture confirmed. The Soyuz MS-14 will remain docked to the orbiting outpost for just 2 weeks before returning to Earth. If all goes well, future manned missions will use the new configuration, starting with the Soyuz MS-16 flight in March 2020. You're listening to Space Time. I'm Stuart Gary. The first test flight of Boeing's new CST-100 Starliner crew transfer capsule has been delayed. The unmanned test flight to the International Space Station was originally slated for April. It was then bumped back to August the 17th before being moved to September the 17th and now not before October the 6th at the earliest. Now all these delays mean the first manned test flight of the Starliner won't occur now before December the 30th at the earliest. That's at least 2 months later than originally scheduled. The Starliner capsule, together with SpaceX's new Crew Dragon 2 spacecraft, are being developed as part of NASA's Commercial Crew Development Program to have private companies handle crew transfer operations to and from the space station, allowing NASA to focus on deep space missions. SpaceX and Northrop Grumman are already handling cargo services to and from the space station, and they'll be joined soon by a third operator, Sierra Nevada. SpaceX's Crew Dragon 2 capsule undertook its unmanned maiden test flight to the orbiting outpost on a Falcon 9 rocket back in March. But a devastating explosion during a failed static fire ground test destroyed a Crew Dragon 2 capsule at Cape Canaveral in May, pushing back Dragon's first manned spaceflight from August to the end of November. The problem occurred when a small amount of nitrogen tetroxide leaked into a helium line used to pressurize the propellant tanks during pretest processing. As a result, the pressurization of the system just before firing damaged the check valve and resulted in the explosion. When it finally does make it into space, the CST-100 Starliner will fly on top of a United Launch Alliance Atlas V rocket, although it's also compatible with the Falcon 9, the Delta IV, and the new Vulcan rocket, which will eventually replace both the Atlas and Delta launch systems in 2021. Both the Starliner and the Crew Dragon 2 are reusable, and each are capable of transporting up to 7 crew members at a time. However, while the Dragon returns to Earth by way of a splashdown at sea in line with earlier Mercury, Gemini and Apollo capsules, the Starliner will touch down on land, just like the Russian Soyuz. After successful unmanned and manned test flights, the Starliner will be certified by NASA to perform regular crew transfer flights to and from the International Space Station. The United States has not launched astronauts from its own soil since 2011, when the Space Shuttle program was mothballed. So currently, Russian-made Soyuz spacecraft deliver all crew to the space station, charging between $60 and $80 million per trip. And time now to check out the night skies of September on Skywatch. September is the 7th month of the year on the old Roman calendar, which are just 10 months. That's before the addition of January and February. Of course, that 10-month year is still reflected today, with the names September or Septem, Latin for 7, October or Octo meaning 8, November or Novem 9, and December or Deci meaning 10. Highlight of the month, of course, is the September equinox, which this year will take place at 1750 Australian Eastern Standard Time on the evening of Monday, September the 23rd. That's 3:50 on Monday morning US Eastern Daylight Time and 7:50 a.m. Greenwich Mean Time. The equinox marks the point in Earth's orbit around the Sun, when the planet's rotational axial tilt means the Sun will appear to rise precisely due east for someone standing on the equator, and set exactly due west. It also means almost equal hours of daylight and darkness. In fact, the very word equinox is derived from the Latin, meaning equius or equal, and nox meaning night. It all comes about because Earth's rotational axis is tilted at an angle of about 23.4 degrees in relation to the ecliptic. That's the plane created by Earth's orbit around the Sun. Earth's axis tilts to the same direction in space, regardless of Earth's orbital position around the Sun. On other days of the year, either the northern or southern hemisphere are tilted more towards the Sun, but on the two equinoxes, around March the 21st and September the 23rd, the tilt of Earth's axis is directly perpendicular to the Sun's rays. For those in the northern hemisphere, of course, it marks the start of autumn or fall, while those of us south of the equator are moving into spring. Okay, let's start our tour of the September night skies by looking to the east and the constellation Capricornus, the goat. It all comes from an ancient Greek tale of the demon Typhon, who emerged from a fissure in the earth and attacked Zeus, the king of gods, during a banquet. The flute-playing goat boy Pan tried to escape by turning into a fish and swimming away. However, his guilty conscience got the best of him and he changed his mind before completing his transformation and distracted the demon by playing his flute, thereby giving Zeus enough time to use a thunderbolt from the heavens to frighten Typhon away. Because of his actions, both brave and cowardly, Zeus placed Pan in the sky forevermore, and he's still there in his half-goat, half-fish guise. The brightest star in Capricornus is Delta Capricorni, also known as Dene Balgeti, or the tail of the goat. It's located about 39 light-years away. A light-year is about 10 trillion kilometres, the distance a photon can travel in a year at the speed of light, which is about 300,000 kilometres per second in a vacuum and the ultimate speed limit of the universe. Dene Balgeti is a spectral type A white beta Lyra variable eclipsing binary, comprising two stars closely orbiting each other. The total brightness of the system changes, in other words becomes variable, because the two component stars periodically pass in front of one another as seen from Earth, thereby blocking out the light from the other star in the system. The two component stars of Beta Lyrae systems are always massive giants or supergiants, so close to each other that their shapes are heavily distorted by their mutual gravitational forces, giving them ellipsoidal shapes with extensive mass flows from one component star to the other. Just below Capricornus on the eastern horizon, we find the constellation Aquarius, the water carrier to the gods. Greek mythology describes the water carrier as the most stunning-looking youth that ever lived, and so he was carried from the earth up to Mount Olympus by Zeus in the guise of Aquila the eagle, in order to become the water carrier. The two brightest stars in Aquarius are Alpha and Beta Aquarii, a pair of luminous yellow supergiants that were once massive spectral type B blue-white stars. The pair are moving through space perpendicular to the plane of the Milky Way. Beta Aquarii, also known as Tadal al-Sud, is the brightest of the pair. It's a multiple star system, located about 540 light-years away. The primary star in the system has about 6 times the mass of the Sun, yet it emits roughly 2,300 times the Sun's luminosity, implying a radius at least 50 times that of the Sun. Beta Aquarii also appears to have at least 2 companion stars. Both are faint, and you'll need a decent-sized telescope to see them. The second brightest star in Aquarius is Alpha Aquarii, also known as Tadal Malik. It's around 520 light-years away and around 6.5 times as massive as the Sun, with some 3,000 times the Sun's luminosity. Okay, now let's move to the southern constellation of Pisces Austrinus, the southern fish. The brightest star in the constellation is Fomalhaut, the mouth of the southern fish. It's also the 18th brightest star in the sky. Thousands of years ago, Fomalhaut used to mark the position of the winter solstice, the Sun's most southerly position as seen from the northern hemisphere. However, what's known as the precession of the equinoxes has moved the northern winter solstice to its new position in December. You see, the exact timing of solstices and equinoxes change from year to year, impacted by what's called precession, which occurs because Earth's spin axis wobbles ever so slightly like the axle of a spinning top. The rate of precession is only about half a degree per century, so people don't notice it on human timescales. Because the direction of Earth's axis of rotation determines at which point in Earth's orbit the seasons occur, precession will cause a particular season, for example the southern hemisphere summer, to occur at a slightly different time from year to year over a 21,000-year cycle. At the same time, Earth's orbit itself is subjected to small changes called perturbations. You see, Earth's orbit is an ellipse, and there's a slow change in its orientation which gradually shifts its point of perihelion, Earth's closest orbital position to the Sun. These two effects, precession of the axis of rotation and the change in the orbit's orientation, work together to shift the seasons with respect to perihelion. Now, because we use a calendar that's aligned to the occurrence of seasons, the date of perihelion gradually regresses through a complete 21,000-year cycle. Located only 25 light-years away, Fomalhaut is a spectral type A white-yellow star, with about twice the mass of the Sun and about 16 times its luminosity. It's also a very young star, only about 400 million years old. That compares to the Sun's 4.6 billion-year age. Fomalhaut emits excess infrared radiation, indicating it's surrounded by circumstellar dust. It's also part of a triple star system, together with a spectral type K orange dwarf star, TW Pisces Austrini, and a spectral type M red dwarf star, LP 876-10. Okay, let's turn to the north, and there you'll see the constellation Pegasus, the winged horse of Greek mythology. It was Pegasus who delivered Medusa's head to Polydectes, after which he travelled to Mount Olympus in order to be the bearer of thunder and lightning for Zeus. The brightest star in Pegasus is the orange supergiant Epsilon Pegasi, which marks the horse's muzzle. Almost 12 times the mass of the Sun, it's a spectral type K supergiant, nearing the end of its life. Astronomers are still debating whether it will end its days a core collapse supernova or a rare neon-oxygen white dwarf. Also in the north is the constellation of Cygnus the Swan, which lies on the plane of the Milky Way galaxy. Cygnus contains the star Deneb, one of the brightest stars in the night sky and one corner of the Summer Triangle. It's also home to the giant Cygnus OB2 stellar association, which includes NML Cygni, one of the largest known stars, a red hypergiant with some 1,183 times the radius and 50 times the mass of our Sun. NML Cygni is located around 5,300 light-years away. Cygnus is also home to Cygnus X1, a powerful galactic X-ray source which became astronomy's first widely accepted black hole. It was discovered in 1964 and remains among the most studied astronomical objects in the sky. The black hole's estimated to have around 14.8 times the mass of our Sun, all crammed into an event horizon with a radius of just 44 kilometres. Located just above the northern horizon is the star Vega. It's the brightest star in the constellation Lyra and the fifth brightest star in the night sky. Vega has about twice the mass of our Sun. It's a relatively young star, less than 500 million years old, and it's relatively nearby, just 25 light-years away. Now, due to the precession of Earth's rotational axis, we spoke about that earlier, Vega used to be the northern pole star around 14,000 years ago, and it will be so again in another 12,000 years. Just above Vega is Alpha Aquila, or Altair, the brightest star in the constellation Aquila. It's a spectral type A white-yellow star with about twice the mass of the Sun. Altair is another near neighbour, located just 16.7 light-years away. It rotates very rapidly, with an equatorial velocity of around 286 km per second, and that's a significant fraction of the star's estimated breakup speed of 400 km per second. In fact, its high rotation means Altair is not perfectly spherical, but it's flattened at the poles. Altair is the eye of the eagle that carried Aquarius up to Mount Olympus to become the water-bearer for the gods. Okay, let's turn to the southeast now, and there you'll see the star Achernar. It's the brightest star in the constellation Eridanus, the river. Located about 140 light-years away, Achernar has some 7 times the mass and 3,000 times the luminosity of our Sun. The star rotates so rapidly that it's elliptical in shape, with its equatorial diameter about 56% wider than its polar diameter. September also sees the bulk of the Origids meteor shower, produced as Earth passes through the debris trail left behind by the comet Kess C1911N1, a long-period comet which only reaches the inner solar system every 1800 to 2000 years. The meteor shower runs between August the 28th and September the 5th. The Origids provided up to 5 swift and bright meteors per hour during its peak just before dawn back on September the 1st. Now, if you're south of the equator and you missed it, don't worry, it was best viewed from the northern hemisphere. That's because its radiant, the direction from which the meteors appear to be coming from, lies in the northern sky constellation of Central Regia. The second meteor shower of this month is the Epsilon Perseids, which run from September the 5th through to the 21st. Now, although they're called the Epsilon Perseids, their radiant actually lies in the direction of the star Beta Perseus, or Algol. Don't confuse the Epsilon Perseids with the Perseid meteor shower back in August. That's because while they both appear to have their radiant in the constellation Perseus, they're actually caused by debris trails from 2 very different comets. You're listening to Space Time. I'm Stuart Gary, and that's the show for now. You can subscribe and download Space Time as a free twice-weekly podcast through Apple Podcast iTunes, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audio Boom, from spacetimewithstuartgary.com, or from your favourite podcast download provider. Spacetime's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C., and available around the world on TuneIn Radio. If you want more Spacetime, check out our blog where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us on Twitter through @StuartGary, at Spacetime with Stuart Gary on Instagram, and on Facebook, just go to www.facebook.com/Spacetime with Stuart Gary. Spacetime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to Spacetime with Stuart Gary. This has been another quality podcast production from Bytes.com.